Welcome to part 4 of the training. I just want to show you what you can do in CPT here. I've just renamed this controller offline and real FG32. I could change that name and call that AHU now. And when I open it, I don't even need to save it, just open it. It will save that. So open it up, close it, open it again, and you will see we have AHU. Now there is a good reason why we do this. You can keep on adding new controllers. You could have hundreds of them. Now you can also add new projects. The reason we do this is so you can find things afterwards, especially where you've made your graphics. So I'm going to call this Medical Center, and that will be a new project, and then I fill it with controllers. So my Sedona app here is going to become the chiller plant. Oops. Let's type it in again, chiller plant. Press open, and it will just save everything. So get used to opening and closing it and changing things. I went for the wrong kit, that's why we got that error. Go for FG, and that will bring up our wire sheet again. So we've not touched graphics yet, but the reason for doing it this way is all to do with graphics. So if you go and have a look here now, Medical Center, you have a chiller plant, you press open, and that opens very nicely. Okay, once that's open, let me show you why we do this. So I go into my documents, EasyIO folder, I go to the CPT files. Now I've got some that I made earlier in here, but the one you're looking for is the Medical Center. Here it is, chiller plant. You see, when I do graphics now, they're all going to be saved there, even if I have or I haven't deployed the graphics into the controller. So it's really more for organization. Some people run these off a USB drive or a USB stick or even off Dropbox so that they don't lose anything. Even though it's all contained in the controller, you can download the graphics later and edit them. And that's one of the reasons we have an SD card in the controller. We try and keep everything backed up for you. So now we will log in as the AHU this time. And this section is all about talking about how we create logic and get comfortable with the wire sheets. This is the basic part of the course. There will be another advanced version coming after these 8 videos, and we'll do some specialty ones as well. So just keep following, and you'll be in great shape. So as you can see here, all these drivers are installed. Now have you noticed, if you look down at the library, it's not shown, and there's a good reason for that. Because we're not connected to the controller, we're connected to kit management. If you double click on these AFG, you're then connected to the controller and the library appears. The service folder shows you the time, the IP settings, this is where you change those. The platform tells you which firmware you're using here. There's a nice feature here for power failure. You can have it backed up every 12 hours in the flash. We have a TCOM service, a serial. You don't have to do anything with these. And the benchmark's telling me that every object in the station here, in this application, is being scanned 49 times per second. I would say that's pretty fast. Okay, let's now make a folder. To make a folder, you use this library down here. The sys has a folder in it. You just grab it and drag it in, and then name it here. We're going to call this cool. If I do the back button, the undo, put your mouse here, undo, and undo again. You can go back or forward 18 times if your memory is that good. Now, I prefer right-hand click. Anywhere in the wire sheet, you can do a right-hand click, add object, and you just scroll down to add a folder, just here, rename it, cool. Now, what you do then is you can just go down the way. You can arrange vertically or horizontally. I'm going to arrange vertically. And get used to hitting this save button here. You can set this yourself to do it automatically. If you go into tools, there's many things you can do in here. We'll cover some of them later. But if you go into options, you will see we have an auto save here. You can set the time, you can enable it, you disable it, and you can also preset your grid size and your number of decimal places. So a little bit of housekeeping there. You hit the save button. When you save, the asterisk that would have been here before has now disappeared. Double click on cool. What we're going to add in now is what we call a ramp object. We'll go to control, go to ramp, which is here, And we're going to make it run from 55 to 85, and we're going to make the delta 0.5. And as you can see, it's just running away, just going up and down as a sine wave, not really doing much, but great for simulating things. So let's now add in a thermostat. So you go to the control block. Again, if you want any documentation on any of these, you go into the FG user docs and look for the standard, open standard Sedona kits. I'll show you again in a moment because it's super important that you use those documents. So let's go down here, find a T-stat, there it is. I take the output to be the CV, which means control variable. Hit the save button again, just get used to doing that. Then I want to put a set point into it, so again right click. You can do it from the library if you like, but I like this method because it remembers the last one you did. I've got all these here that I can use, so when you get used to it, it just makes it a lot faster. So just go down to the control kit, go up to here on the right and go for a writable float. That's going to be our set point. I'm going to rename that set point. And just move that so it looks nice and link the output to the set point. And save it. And we're going to use the output to switch a relay. So I did use one of these earlier, so it should be in here, and there it is. Look, easy ODO. I don't need to actually go to the kit. I just go to the recently used. I call it relay number 1. Take the output is true to in there, and I just heard the relay come in. I could put a little bit of differential in there if I wanted. I could make it heating or cooling here. And where's my differential? If I just enter a value here, say 1, that just puts a little bit of deadband across the set point. And that relay will come on and off depending on what we put in here as the set point. So if I set the set point to be, say, 75, we've got our first little bit of logic there. Okay, the other thing you can do with logic is I want to get you used to using your user libraries. I call this jigsaw programming. Let's say we wanted to use this again. I could just highlight all of this and right click anywhere. You've got all these red lines around here now. Do a right click and just do create user library. And I'm going to call this T-stat. Rather than default now, I've already created a folder called training examples. So just to show you how you do it, I'm just going to call it training. And what it does is it creates a folder for you, and I can now delete this. And I have two choices. I can go down to this tab at the bottom left hand corner. You've got kits and you've got user libs. If you find your library's disappeared, it's because this is tabbed. You just go back to your kits and click on here. But on user libs, you'll see now we have training and we have T-stat. I can just drag that in, and you can build some really nice libraries by doing that. If you find this happens and you can't see the links, just save it. Double click on here. It's just a memory thing. Double click on here and you'll see everything's back again and it's all working. The other way you could have done that is delete that and do a right hand click and do user lib training T-stat. I think that's a really nice way of saving things. You could also save the whole folder if you wanted. You could just do cool, create user lib, decide where you're going to put it, which is training, and call it cool folder. So with logic and links and everything, it gets saved. So I could delete that now, right click it, add user lib, training, cool folder. There it is back again. It's just like magic. No, it's easy, and this is live programming in the controller. So now let's just delete what we just did. I'm doing this fairly fast, but you can keep playing it back and keep on just trying examples, because I've actually created some for you. But what I want to show you next is in the folder that where my EasyIO 2017 folder is. If I go to the user guides, I was just going to show you again where the documents are. Sedona open source kits will tell you everything you need to know in there. So if you want to look at that thermostat object that we just used, it would be in here. It's all in alphabetical order. There's T-Stat. You click on that and it shows you and tells you what it does. When we get to the more detailed ones, anything outside of that control kit is an EasyIO kit, and it's all covered in here. Sedona Kits V1.3, and we go into all kinds of stuff in there, really sophisticated and powerful, but also simple. So while I'm in this kit, what we're going to do next is we're going to have a look at our kind of exam paper, as we call it. It's not really an exam, as I mentioned before, but if you look down here, there's lab test. Double click on that, and this is a document. You need to do this to get certification after watching these videos. All you do is complete what it says at the end of the video, and then you can do this yourself and get certified, and we'll send you a certificate. So if you see, there's the cool folder. It tells you how to create a cool folder in this app. We're going to actually do this as part of the training. So let's create that cool folder. Add folder, type in cool, double click on it. I'm going to go fairly fast, but you can always slow this video down. Let's add an object. Let's add the PID loop. Now you go to the common kit and you add the single loop here. Bring that across. Rename it as PID. Okay, just call that PID. And just save that. Click on here. Make those vertical. Tidy them up. Double click on cool. There's our PID loop. Now we're going to add a writable float. This is going to simulate temperature and set point. So we can go to control, writable float, copy and paste. That gives us 2. Now a nice feature of CPT is that if you highlight more than one object at a time, you can fill them all in. So why don't we go in and just fill out everything in one go and then link them together. So the first writable float is going to be our temperature, and we're going to make that on the in 75. This is just for simulation. On here, on the PID, we're going to set the set point. It's going to be linked to the object, so we don't need to set that just yet. But the deadband's going to be 6. Sorry, the throttling range is going to be 6. Integral is going to be 0.1. If you want more details on this, you go to the documents that I showed you earlier. You'd go to the EasyIO Sedona kits, and it would tell you how to do it. Then you go to your third object, make this set point, and we're going to make that 75. And we're actually going to change this one to 77. You can do everything in one go. It's really cool. Take the out now to the process value. Now, when you want to link the set point, you're going to see that you can't see it. So what you do is you click on this. It opens the whole object so you can see all the slots. Then you can see set point. But watch what happens when you link it and then make it small again. Put the set point in. It remembers that slot name. Now you can see set point. So that's really nice. And then we add an output, which is going to be an FG. FG is always for any physical hardware points. So you'd go to the UO. You'd call this valve, because the test tells us to do it that way. And again, while we're in there, we can just get everything set up. Tell it it's going to be voltage. We want percentage 0 to 10. And we want the channel to be the first analog output. We put the out to the in. So that's some very simple logic there. If you want to take a look at that, go to the lab exercise and go to page 15. So while you're playing, you could always go and just take a look. Only when you get to the end of all these videos and you do the test, you're going to go through this in a very orderly fashion. Now let's save this as one of our little jigsaw pieces so we can use it again. Let's do a create user lib. Call this cool logic. I guess it is cool. And signal that, go down to where we put training before and press OK. So now that has saved the logic, but I actually want to save the folder as well. So again, go to the folder, create user lib, and this time call it cool folder, and link that to the training again. It says yes, already exists. It was one I did earlier. So this is what you've got in summary. If we were to delete that and go to add user lib, go to the training and go to the cool logic, our logic comes back. If we were to go to the main workspace here and delete the folder, do add user lib, we can then put in the folder, and inside is the logic. Okay, now you can also copy groups of folders. So I've had to cheat a little bit to save time. So what I've done is I've gone to somebody's completed training application that they've submitted, someone who passed, and I've created little jigsaw pieces. So if I go to training examples, you'll see I have a way of doing the schedule, say the vent logic. So you'll see in this test, you go down and we have to create a vent folder. Let me see if I can find it. This is very self-explanatory, this document. You'll find it pretty easy. Yeah, there's the vent folder. So everything that's in there, I've saved from somebody else's test. If you go inside it, somebody else's test looked like that. The other thing I've done is I've created some starter sheets for you, and I'm going to send you these user libs, and all you do is you copy them into here. So go back to your, well, I've actually got it open. Go back to your EasyIO March 2017 folder, open it, go to user libs, go to wiresheets, go to training examples, and they're what we call .cps files. You just paste them in there and you can use them. Just straighten all those up. Now I'm going to add a few more, show you how you really build up an app. I'm going to now add user lib, go in and add training examples. I'm going to add a sensor. So if you go through this, you'll see how you add a sensor. I've done it so I can simulate it. In reality, I would break this link and link it to the UI. But at least you get some simulation. I did another one like this. If you just go into here, and now you want to add BACnet, complete starter, so you've got server and client ready to go. Go to BACnet starter. Double click. You'll have a BACnet service. You'll have all your BACnet points. There's the server, and there's some pre-made points that I've done for you that are going to be typical what you need. So if you were to restart this controller afterwards, BACnet, you need to do that and make sure everything's enabled. You'd be able to discover that from another BACnet system, another BACnet client. I'm then adding another one, user lib. I'm going to add histories this time, SQL database, history SQL. These are all the kind of things you're going to need in any type of system. So there's your SQL. Inside is your table called chiller, and there's a chiller flow. I've only just done one column for it. But we'll be covering this better in the later videos. I just want to show you how you can easily put these in without wasting too much time. Let me see what else I had. I did a schedule folder as well. Now the schedule comes in. And if we were to complete as per the test, the one thing I didn't do in here is on the cool folder, you will see on the PID loop, I didn't enable it as an enable point. That's why the valve is staying closed. So let's show you how you link objects now. Do a right click on the object that you want to link, say make link, you get this little matrix. Now I want it to be the reverse of this. So if I hit switch, the PID is now open, waiting for me to tell it what I'm going to connect to it. Well, I'm going to connect the schedule to the enable, called enable, out, PID, enable, link. And then the DO, which is occupy, this will all be evident when you do the test, or if you just read through page 15, 16, 17, 18. If I take the out here, PID, and do occupied and link, I now have two links. You'll notice the valve opened. So if you look at the PID loop now and you move right down the bottom right hand corner, you've got properties, links, and you've got slots. So if you wanted to look at what links are made on this particular object, where they're coming from and where they're going to, they're summarized here on the right hand side. So it's a great way to find what's been linked between all the different folders. Now let me show you one last trick. If we want to save these folders, and a word of warning, never delete the service folder. So it's always wise to keep these away. It will crash the controller if you delete the service folder. So what I'm going to do now is copy all these folders into my jigsaw. and I'm going to call it typical project. So I'm going to do training, so I'm going to do create user lib. It takes slightly longer to save because it's saving more. I'm going to call it typical project. I'm going to put this in training. I'm going to press OK. Then I'm going to delete everything. It's all gone. This is live program. This is straight into the controller. So if you now did add user lib, training, typical project, all those would come back, including the links. To prove it, if we were to look at the cool folder, you will see the links are there for the enable and the ones that we just made. Sometimes you just have to double click on it to get them to come in. There they are. Another way of looking at the link is to go down the bottom left and you'll see the link there. So there's a quick overview of how you do basic programming, how you save pieces, and how you pull them back in.